today we are just going to discuss about the functionality of Python objects and classes. And we are also just going to add up with how to create it and use it in your program. Okay, let me just see from the beginning. So Python is an object-oriented programming language. Everything in Python is an object with its properties and methods. A number, string, list, dictionary, or tuple, or set, etc. used in a program is an object of a corresponding built-in class. We create class to create an object. Unlike procedure-oriented programming, where the main emphasis is on function. So object-oriented programming stresses on objects. So an object is simply a collection of data, which is variables and methods, which we just say as functions that act on those data. Similarly, a class in a blueprint for that object. We can think of class as a sketch, that is a prototype of a house. So it contains all the details about the floors or doors or windows, etc. So based on these description, we build the house. So house is the object. So as many houses can be made from the house's blueprint, we can create many objects from the class. An object is also called as instant of the class, and process of creating this object is called instantiation. So we instantiate a class to create an object. So the class defines attributes and the behavior of the object. While the object, on the other hand, represents the class, we have been working with classes and objects right from the beginning of this challenge unknowingly. So every element in a Python program is an object of a class. Let us first check if everything in the Python is a class or not. So see here, dear friends, when on just making the check of each and everything, see here, I'm just going to execute one by one, whereas the first one is a variable, integer variable, there next is a string variable, and next we have provided a boolean, list, tuple, set, and at last a dictionary. And see here, as we have already said, this is each and everything are in a class. Everything is in a class. Okay, now defining a class in Python. Like functions, definitions begin with the def, that is the def keyword in Python. So class definitions begins with the class keyword. So here we have just provided the syntax. Okay, so the first string inside the class is called docstring and has a brief description about the class. Although not mandatory, this is a highly recommended. So wherever I just provide any classes or create any programs or anything, usually I just give a comment or a docstring. Fine, dear friends, let me just move on to this example. See here, a class creates a new local namespace and where all its attributes are defined. So attributes may be data or functions. There are also special attributes in it that begins with a double underscore. For an example, here we have just used it in the first example. So double underscore dog and suffix with the double underscore, which gives us the docstring of that class. Here we have already provided the docstring. Here we have just provided. Okay, so as soon as we define a class, a new class object is created with the same name. So this class object allows us to access the different attribute as well as to instantiate new object of that class. So kindly have a note of it, dear friends. See here, the class person has been created, and here we are having a variable age and we are having a function which is a method is greet. And when we just call the function that is greet, it would just gives you the exact what is the function to be called, or what is the performance actions to be taken as the statement below the functions. So how you would call the functions or the variables? By the class name. And see here, dear friends, this is the class name and this is the variable. And this is the class name and this is the function. And here we are just giving the instantiate which we just get our built-in functions that gives us the doc strings of that class. Okay, let I just execute it. Dear friends, kindly have a look of it. So age, we have already declared the value as 10. So it's just providing. And next one, it's a greet. Actually, greet is a function. So it's just giving us the value of a function and data type. And next, it just gives you the exact location. And this is a person class. So this is the exact doc string which we have just created. Now, once on every creation of a class, the object has to be initiated. So now, how to create an object in a Python? See, we saw that the class object could be used to access different attributes. So it can also be used to create new object instance of that class. So the procedure to create an object is similar to a function call. So here for an example, if we just have Harry is equal to person function, so this person is like a calling the function call. And this will create a new object instant named Harry. Here we are just having a see, when we just make use of this age is equal to 10, age is the exact variable you are initiating. You are just initiating a value variable and you are just making a value as 10. And to the same, when on making this foreign class, you are initiating a object by the name Harry, and where it has the members and functions, that is variables and the functions according to that of class which we are just assigning age. So we can access the attributes of objects using the object name prefixed. So attributes may be data or methods. So methods of an objects or corresponding functions of that class. So this means to say, since this person dot greet is a function object, so which is an attribute of the class. So here person dot greet will be a method object. So here it would be a method object anyhow. Let me just execute this, dear friends, and see here. And see here, this function, when we just call that of greet, it is a function. But when we just specify the object, it is exactly bounded with the method. That is method of that function. That is attribute of class. That is how it would be. And see here, dear friends, I just want to specify one thing. See, you may have noticed that self parameter here in function definition inside the class, but we call the method simply as harry.greet. So without any argument, it is still worked. So this is because whenever an object calls its method, the object itself is passed as the first argument. So harry.greet translates into how it just done, person dot greet of Harry. So in general, calling a method with a list of an argument is equivalent to calling the corresponding functions with an argument list. So that is created by inserting the methods object before the first argument. Before the first, okay, let I just give you the exact how it has happened. I just make it in a comment box. So instead of Harry dot greet function, how it just happened is as like person dot greet of Harry. So this is how it happened. So for these reason, the first argument of the function in the class must be the object itself. So this is conventionally called self. So it can be named otherwise, but we highly recommend to follow the convention. So now you must be familiar with class object, instant object, function object, method object, and their difference. Okay, so here it is, the person is a class object, and when we just make use of the Harry as an, it is an instant object, and greet is a function object, and from that this greet of Harry is a method object. Okay, fine, let me just move on to constructors in Python. In Python, if a class functions that begins with double underscore are called a special function, as they have special meaning. A class without a constructor is not really useful in real application. So a constructor is a special type of method used in Python to initialize the object of a class. So the constructor will be executed automatically when the object is created. If we create three objects, the constructor is called three times and initialize each object. So the main purpose of the constructor is to declare and initialize the instant variable. It can take at least one argument, that is self, which we just specify here as double underscore init double underscore. So this method is called the constructor in Python. So in other words, the name of the constructor should be like this. Inside we have to specify in self. And for your information, dear friends, a constructor is optional, and if we do not provide any constructor, then Python provides the default constructor. Each class in Python have a constructor, but it's not required to define it. Okay, let me just execute this program. I just executed. See here, dear friends. So here, what we are just making it, we want to create a class as we created a class as complex number. And for that complex number, we just given a real value and the imaginary value. And that attribute here we have just specified as R and I, and we just called the exact value. We are just waiting for the values from the user as a to attribute. And when on calling the get data, that is the method, when we just call that member of object, we here it just specify dot real and dot imaginary of that part where when on just creating the initiation. So see here, C1 is the object of the class complex number, and when we just call C1 dot get data from the method of that class, yeah, it is just going to print the value, that is the action just going to do under the statements of the function get data. And see here 5 is the real value and 6 is the imaginary value. Okay, now let me just make a complex number still more complex. Yeah, see here, dear friends, what we have done is the same function. Till this, it is not a problem. Till this, it is not an issue. And here the num1 is the exact object of complex number 2 comma 3, and it is just going to get the data, and whereas it is outputting it as 2 plus 3j. Yeah, exactly, it is going to do. And secondly, it is just going to call it again. Okay, it is just going to call it again, where when on just calling this, what would be the attribute here is, here we are just going to give only one attribute, and when on just making that out attribute, here we are just making a new attribute as attr, which we are just making it as 10. And see here, dear friends, here we are going to print, okay, we are going to print, that is num2 dot real, which is already 5. Yeah, we know that. Num2 dot imaginary, that is not given or not provided by the user, so it would be 0. And num2 dot attribute, where we already just making an initialization directly from the value, we are just getting it as 10. So till this, there is no issue. But when we are just making num1 dot attribute, see, actually we didn't make anything num1 dot attribute, we didn't have it. So this exact num1, it doesn't have the attribute. If you want to make here, yeah, it just going to have an error. So let I just execute it. So expecting an error that attribute complex object has no attribute attr, whereas num1 we don't have attribute. If you want to have what is that of num2, yeah, we would get the value 10. See here, we just get that value 10. But when we just make this as num1, we just get an error add to the top floor. So then in the above example, we define a new class to represent complex number. So it has two function, that is, one is init to initialize the variable, that is default to 0, and next one to get data to display the numbers properly. An interesting thing to note in this above step is that the attribute of an object can be created on the go, that is on the fly. So we created a new attribute attr here for the object 2, that is num2, and read it as well. But this doesn't create the attribute for object 1. That's we received an error here, that is attribute error. Okay, let me just move on to the next one. Type of constructor. See, actually we have two types of constructors in Python. One is non-parameterized, that is the constructors in Python which have no parameter is known as the non-parameterized constructor. So the non-parameterized constructor uses when we do not want to manipulate the value or the constructor that has only self as an argument. The next one is a parameterized constructor. Yeah, it is the vice versa. So the constructor with the parameter is known as the parameterized constructor. So the parameterized constructor has multiple parameters along with the self. Okay, let me just have the same with parameterized and without parameterized. So let me just execute this, that is without parameters, which is a non-parameterized. So see here, dear friends, so here we are just going to have a constructor. It is a self constructor, and here we are not going to have any parameters, and this is non-parameterized constructor. And when on just calling the method show, it's just going to show the name which you are just going to get it as an instant method. So here we are just going to have that Arthur as the name of the function. Okay, that is the parameter of the function. But here we are not having the constructors. There is no parameters in the constructor. Okay, so let me just execute it and see here the result. This is non-parameterized constructor. And see here, dear friends, let we create a parameterized constructor with the parameter name and color. And when we create an object of test, that is the class called object, the parameters constructor will be executed automatically. And here we are just having the function as class as fruit, and here the object is obj. Okay, so here the fruit and the obj is the exact one. And when we just create an object of this fruit, and the class called the obj function, which it has a parameterized constructor. And let I just execute it, dear friends. Kindly have a look of it. So see here, the fruit is apple and color is red. So here we are just replacing, that is the placeholder, that is fruit is apple, the first parameter apple, and next it just comes the self dot color, which is an red, that gives the second parameter value. Okay, let me just have one more example with a parameterized that. See here, we are just creating a class student and initiation, that is also in student in lowercase. And see here, we are having a parameters of one parameter name. When we just make use of that call, here we are just making only the name of the self, and here it is just going to create, that is it is just going to replace the value of that attribute. And here what is the value? It is world. So here it is just going to print as hello world. And see here, dear friends, as the constructor, we are just having a print functionality. So this is parameterized constructor, so this is going to print first and then it goes the hello world. Okay, next we just make one more examples how to create an object in Python. See here, dear friends, we are having a master student class, and in that master student class, we are having an attribute for class, that is spices, which we are just equivalent to students. Okay. Apart from this, we are having a parameterized constructor with name and age as the parameter, and we are just making it the valuation of self.name and self.age. Okay, we are just creating here as the instantiation of this, sorry, okay, fine, instantiate the master student class functions. Okay, and here we are just naming it according to the name which we have provided as one among the parameter, to just not get confusion. So see here, dear friends, we are having Jane, Bella, Candy, Lucia and Ran, and all these things we are just totally creating 5 instantiation of that master student class, and so that it exactly been created. But when we just access the class attributes only for the Jane and Bella, this two alone, it is just going to get printed. And see here, what is the placeholder value is the exact Jane class spices. And what are all the spices? It is about the student, and that students here, it just gives the value of it. Okay, and here it just gives the species value. So let I just execute and see here, Jane is a student and Bella is also a student. Okay, dear friends, let me just see and one more example and see what it here is. Creating a class, a student, and common base class for all students is the exact attribute. What we are just going to have is student underscore count is equal to 0. So that is what the class attribute. And we have initiated the parameterized constructor with name and ID, where here the name and ID we are just having as an attribute from the function, but here we are just going to have a count incrementation of each and every time when it just get instantiated. Okay, so here we are just having the print student data. This print student data is the function, and see here, dear friends, the variable student class, sorry, student underscore count is a class variable whose value is shared among all the instance of a in this class. So this can be accessed as student dot student count, so from inside the class or outside the class, anywhere. So here it is called inside the constructor. And the first method here, initiate, is a special method which is called the constructor or initiation method that Python calls when you create a new instance of this class. and you declare the other class methods like normal functions, with the exceptions that the first argument to each method is self. And Python adds the self arguments to the list for you, and you do not need to include it when you call the methods. And see here, dear friends, when I just make use of this, and see, this is going to be the printing one, where I just get the self.name as mark here and self.id as 101. Let I just execute it, and see here it is the output. Okay, next let me just see about the creating instant object. See, to create instant of an class, you call the class using the class name and pass it wherever argument it's as double underscore init double underscore method accepts. So let's create a student class object of the above example. So above example, we are just having this, and how here it is just done as student mark of and 101. Here we are just creating a student of Vijay and 102. So this is how you can just create instance of any other thing. Okay, so fine. Next, let me just move on to the next one, accessing attribute with self parameter. Okay, see here, dear friends, the self is used to represent the instant of the class. It is the default variable that is always pointing to the current object. So by using self, we can access the instant variable and instance method of the object. So while defining constructor and instance method, the self is their first parameter. It's not required the first parameter named to be self. So we can give any name wherever we like, but it has to be the first parameter of an function in the class. You access the object attributes using the dot operator with class. So class variables would be accessed using class name, as here it is mentioned in the example. So let me just see here, dear friends. So here class is an employee is a class, and we have just defined an constructor, and again we are having an info, that is the instant method of the class. Here we are having two methods, one is info and the next one is department. So as methods including this init has a self parameter, we created two instance variable id and name. And then we created the object of a class employee as emp. So this is the exact object, and when we just make use of the call and access the instance method of that class called info and department. Okay, let I just execute it here. See here, dear friends. So here where it just gets the ID as 19116 and the name is Amy. And once after that, the department is also called, the method department is also called, so it just executing as employee of IT department. Okay, and let me just create some more instant with the other class, and see here, dear friends, class student is there, and as we have seen already, we are just having a common base class for all students as student underscore count is equal to 0. This is the attribute of the class, and we are having one constructor, which is a parameterized constructor, and one method function, and where it's just going to have the self as with just going to execute the name and id of the function. And when on just making the total count of initiation, it just makes each and every time of initiation the increments, the count is incrementing. So here we would just get the count also. So total number of student. And here let I just execute it, dear friends. Kindly have a look of it. See, total number of students is equal to 3 and the name is equal to Milan and with an ID, Vijay with an ID and Chirag with an ID here. Okay, dear, instead of this, using the normal student to access this attribute, you can also make use of the following functions. That is get attribute, has attribute, set attribute and delete attribute. So here these are also the functions which you can also make use of instead of making the access of that attribute, where here we have just specified as student underscore count, and here you can also make use of this. And here I have just provided how the example that can be happen when you can just make use of has attribute, get attribute and set attribute and del attribute. Okay, next it just comes the built-in class attributes. See here, dear friends, where we just have a built-in attributes and they can be accessed by using dot operator like any other attributes. Here we are just making it with double underscore before and after. So here are some of the built-in class attributes which just executes the dictionary or document and name, class name, and it just gives the module and basis. Okay, let us try all these attributes with an example. See here, dear friends, the same student class and it just having the initiation of student 1, 2 and 3 with the name of Milan, Vijay and Kira. And see here, total student count, we are just going to have the count and what is the doc, what is the name of the class and what is the module, base and dictionary. Let I just execute. Kindly have a look of it. See here, dear friends, this is how we would just get the executed value. Okay, next it just comes the object properties. Every object has properties with it. So in other words, we can say that object property is an association between name and the value. So for an example, a car is an object and its properties are car color or sunroof or price and the manufacturer. It can also be added with the model and engine and so on. So here color is the name and red is the value. So let me just see how to modify an object properties. See, every object has a property associated with them, as I have already said. So we can set or modify the object's property after object initiation by calling the property directly using the dot operator. And see here, dear friends, so here we are just making a fruit. Okay, and the class fruit, and we have initiation the constructor, and we have the name as that is the parameter as name and color. And when we just make the fruit, yeah, here we are just going to call it as apple and the color is red. And see here, we can modify the object property. Previously we have just specified as apple. Now we can modify it by just calling the name with the dot operator. Okay, that is the parameter with the dot operator. And see here, dear friends, when we just make use of it, yeah, here if we just make I just command this line. Now see here, the fruit is apple, the color is red. And when I just make the modification, now I execute. See here, the fruit is strawberry and the color is red. Now it is modified. Okay, dear friends, so let me just go for the next. Delete the object properties. Yeah, we can delete the object property by using the del keyword. And after deleting it, if we try to access it, we will get an error. So obviously that is what we are just going to make a try. And see here, dear friends, here in this example, to the same the class fruit, and we are just having the constructor and function, that is the member function, as a show. And here what we are just going to show is apple and red, that is the first property as name and the color. And when on deleting the object, see here, when on deleting the object, and we are not going to have the access to it. First of all, I just command this and execute it. See here, we are getting the object name, and even though we can just get the object color, yeah, it is red. And if we just make the deletion, and if we just check for the object name, yeah, it is not going to display the execution. It is just going to give us an error as the object name is not no more available here. Okay, see here, dear friends, how we just made use of it. And the same, let me just make it with another example. Here, directly object name, we are just going to delete it. Okay, previously we just deleted the property, object property. Here we are just going to delete the object itself. Okay, the same del keyword only, and the object name. And see here, dear friends, with this class employee, and we are having the department ID as the global declared. And see here, we are just calling the function show, and when it's just going to show, yeah, we would just get the output. And when we are just going to make a deletion, and then if we just make a show, it is not going to. So see here, before making the deletion, I just comment it and I execute it. So see here, we are just going to get twice, but when on making it with uncommenting, see here, I'm just giving the del emp here. First it just shows, next as it deleted, this would give us an error. That's, see here, so once it's executed, and for the second time it just gives us an not defined. So this is how after the using the del keyword, which we are just object is deleted. Okay, so where this emp is the object of the class employee. You can also apply it in a small thing, a small functionality. See here, we are already having a complex number, and in that we are just having the real and imaginary value. When we just delete the imaginary, and if we just need to get the access, yeah, it is just going to give you the error only. And same when we just make use of the get data, yeah, that is also, it's just going to give us an error where, see, previously we just got the data here, but when we just make the deletion of the data in the example 3, we are just getting an error. And see here, dear friends, we can even delete the object itself by using the del statement. And how this happens is, see here, with this example I just specify. So C1 is the object and complex number is the class, where we are having the name parameter as 1 and 3. So it is more complicated that than when we do C1 is equal to complex number of 1 comma 3, a new instant object is created, which is C1. Okay, and here it is created in memory, and the name C1 is binded within that. On the command this del C1, okay, this binding is removed. See here how this happens is, when I'm just making the complex number, here the C1 is done, it is binded with the exact memory with the name C1, and it just binds with the real and imaginary. On the command del C1, this exact binding is removed and the name C1 is deleted from the corresponding namespace. So the object, however, continue to exist in the memory, and if no other name is bound to it, it is later automatically going to destroy it, because this automations destructions of unreferenced objects in the Python are called garbage collection. That is, we are just going to have it in the garbage. But here, how the exact binding is not possible when on just giving the delete. Okay, fine. Next, let me just move on to the data hiding. So, an object's attribute may or may not be visible outside the class definition. So, you need to name attributes with a double underscore prefix. And those attributes then will not be directly visible to the outsider. See here, dear friends, when we just make this exact hiding, so here we are just making the private attribute, and when just making the private attribute, the first two count, it just giving the count and addition. When on to the last, if we just execution, it is not going to execute, just as like a counter is not an object or an attribute. So there we getting the error. And see, as for your information, dear friends, this Python protects those member by internally changing the name to include the class name. You can access such attribute as object dot class name underscore attribute. See here, I just specify here like this. So here the just counter and the secret count. So if you would replace your last line as here, where in this previous example, see here, dear friends, how we have just specified counter dot underscore secret count. But here, if we include the class name, then it would be working. And see what would be the count here. So totally we just two counts. Yeah, here it is. And next, last one, an example of converting the dictionary into a Python object. And see here, dear friends, when on coming to the dictionary, we are just going to have the value key and the value. And here, how you are just going to reference the key and value with this data. And here, the data is provided by this. And see, when on just creating the class object, the object is initiated, that is ob is the object that is initiated by the class obj. And when just on printing it, here is our executed data, and which it just shows the conversion of dictionary to Python object. So Python inheritance. And we all know that actually the process of inheriting the properties of the base, that is the parent class, into derived, that is a child class, is called inheritance. So the inheritance enables us to define a class that takes all the functionality from a base class and allow us to add more. So here we are just going to see it by an example. See, inheritance is a powerful feature in object-oriented programming. The main purpose of inheritance is the reusability of code, because we can use the existing class to create a new class instead of creating it from scratch. So it refers to define a new class with little or no modification to an existing class. The new class is called derived class, which is we just say as child class, and the one from which it inherits is called the parent class, that is the base class. So see here, dear friends, in inheritance, the derived class acquires the access of all the data members, properties, and functions from the base class. Also, a derived class can also provide its specific implementation to the methods of that base class. And here I have just provided the syntax. Kindly have a look of it, dear friends. So here it is class, base class, and we have the body of the base class, whatever be the statements under the base class, functions or members and methods. And next comes the class, derived class. From the base class, we have to, from which base class you have to specify here in the parenthesis, and next a colon, and following it with the body of derived class, where you can have the statements under which the derived class to be happened. Okay, next let me just see the type of inheritance. See here, dear friends, in Python, based upon the number of child and parent class involved, there are 5 types of inheritance, and I have listed it following it by the numbers. See, single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and next hybrid inheritance. Okay, let me just see one by one in detail with example. So see here it is the first one, single inheritance. In single inheritance, a derived class inherits from a single base class. Here in one derived class and one base class. Okay, so one derived class and one base class, and here the derived class is derived from the base class, that is the futures of base or whatever be, it just been derived from the derived class. And let me just see with an example. So see here, dear friends, we are having the base class vehicle and a method vehicle info with a self constructor, where we are just going to print only statement as inside vehicle class. When I'm just providing the derived class, see here, dear friends, we are going to derive one object, that is a class which is just a child from the parent, that is one among the vehicle, a car. So here a car is a vehicle, so from the base we are deriving the child car, and it has its own self method function, that is car info. And see here, when on creating an object onto that of that class car, we can have car dot vehicle info from the base class method and car dot car info from the derived class method. This is how you can specify. And see here, dear friends, here is the base class where you have derived the class car from. And let I just execute it. See here, so inside vehicle class, inside car class, where we are just accessing the info by using the car object. Okay, let me just see the next one, multiple inheritance. In multiple inheritance, one derived class can have multiple base class. That is, it can be derived from class 1 also, or it can be derived from class 2. So here the multi-derived class is derived from class 1 and class 2, which is the base class 1 and base class 2. Let me just see it with an example. See here, dear friends, we are having information related to an employee, and that employee separately we can just have the base information related to that person as the class base, and he is an employee to the company, and under the company also his or her information would be there. So when we just talk about this employee, he would be a person or he would be a, employee of this company. And if we just say yeah person, yeah, he would be a father of a person, and he would be a father to a person. Okay, so in that manner, so we can just make that person would be the base of which class it is having the base information. So let me just have this as a multiple inheritance. So class 1, base class 1, we are just having the person, and base class 2 under the company. And according to that, we are having a method person info, and under the company it is a company info. And we are having parameterized functionality, where name and change age comes under the person info and company name and its location under the company info. And when we just have making as a multiple inheritance, so both the base 1 and base 2, we are just going to take it as a base class. So both should be present with a separator comma. And see here, dear friends, if I just create an object of employee, here we are not going to make it for a class 1 or class, that is base class 1 or base class 2. Here we are just creating an object for the employee, and here EMP is the object of the employee, where it comes from emp dot person info. Yeah, it is the name of the person. And when coming to the company info, yeah, here it is the information related to the company and about that employee, and it is person to that of information. So here let I just execute. See here, inside the person class and inside the company class, and here I am inside the employee class. So with this, it is just having both the information from the base class 1 and base class 2. So which it just specify as the multiple inheritance. Okay, let me just move on to with a main example. See here, dear friends, here it is an class first, class second, and class third. And when we just make use of a base class 1, base class 2, and here the third, we are having the base 1 and base 2, okay, as derived, and we are just getting the third class. And when we just call the constructor, that is initiate the object of the class third, and we would be just getting the executed results as first, second, and third. Okay, let I just move on to the next one. See here, dear friends, here we call the same as like mammal is the class. Okay, that is the base class. And here we are having the object to be the class function. And see here, dear friends, when we just have one more class that is derived and which is derived from the mammal class, and see, we call the under double underscore init underscore method of the mammal class from the dog class. And using the code here, see here, we are just using super function dot double underscore init instead of mammal. Here actually when we just make use of derivation, here we have to use mammal dot double underscore init. So since we do not need to specify the name of the base class, when we call its member, we can easily change the base class name where if we need to. So that is the exact advantage when we just make use of the base classes, that is having more than one base class. So we can just switch over to which base class we need, so we just make use of it. So there it just comes the super function. And see here, dear friends, I just execute it. So here dog has 4 legs and dogs is a warm-blooded animal. It is just coming from both of the functionality. So here it is first called, and then it just move on to the mammal, which is the super function method is used. And here I just want to show you one thing, changing base class to the other function. So see here we can just make this dog in any of the function, any of the base class function. Okay, so the super function, it is actually a built-in method, returns a proxy object, that is a substitute object that can call methods of the base class via delegation. So this is called indirection, which we just say ability to reference base object with super function, which is the built-in function. So since the indirection is computed at the runtime, we can use different base classes at different times if we need to, if we want to make a changes. So that is what here it is specified. Okay, let me just move on to the next example in detail. See here, we are having a animal class. Okay, and that animal class is base for the mammal class, and next non-winged mammal is derived from mammal. Again, non-marine mammal, it is also derived from mammal. And see here, dear friends, we are created a dog that is having multiple inheritance as non-marine mammal and non-winged mammal. So here we are having the every functionality of single inheritance and multi inheritance, where this is a continuations, and we are having a super method built in function. So if I just want to change this mammal to just directly, I can just make it animal. Yeah, it can be done. So here how the execution happens, just kindly have a look. So here I'm just creating a object D of dog class. And when I'm just being here in dog, so what it just goes, dog has 4 legs. That is the first one. And next, see here, dear friends, it just move on to non-marine mammal. So which is, yeah, it can't swim. And again it just goes for non-winged mammal. Yeah, here it also just specify it can't fly. And apart from this, both the things are just derived from the mammal. So it just say dog is a warm-blooded animal, and at last dog is an animal. Okay, let I just make a one more calling function as bat, where directly I'm just specifying the class of non-marine mammal. And see here, dear friends, as it is non-marine mammal, it directly move on to this. And what it just print? It print bat can't swim. And where it is derived from? Mammal. So it just move on to the mammal next itself. So here it just say is a warm-blooded animal, and next it is derived from the base animal. So here it is an animal. So let I just check with the execution output. Yeah, see here it is how has been specified. But here we are having all the things with a super function keyword. And why this is, actually the super function is most commonly used with init, that is double underscore init double underscore function in base class. So this is usually the only place where we need to do something in a child, then complete the initialization in the parent. So see here how the exact function syntax would be. So class, and here it is the child class, and when we are making derived from the parent, and that parent here how it has been just made as a self constructor, and here we are just making the self of that child, and with the super function method with underscore a double underscore init double underscore for that. Okay, let me just move on to the private members of parent class. See here, dear friends, we don't always want the instant variables of the parent class to be inherited by the child class. So that is, we can make some of the instant variable of the parent class private, which won't be available to the child class. So we can make an instant variable by adding double underscore before its name. That's it. So how we can just do it? See here, dear friends, we are having a class, that is C is there, and here we are just having the D class, which is derived from the C. And one and only thing, when we just make use of this, note before there are two underscore. But when we just make use of that object one of direct, so it just produce an error. Why? Because here has D has no attributes of this D. This D doesn't have an attribute of that D, because here we are having specifying this is private to this exact function only. So there it is specified the value as like error that this type D has no attribute at the small d. So here how you can just specify is by underscore, you can just specify the private instance. So if you just try to access it, yeah, you are not able to do it. That is what executed here. Okay, let we just move on to multi-inheritance. See here, dear friends, in multi-inheritance, we can also inherit from derived class. It can be of any depth in Python. All the features of the base class and the derived class are inherited into the new derived class. So for example, there are three classes, that is A, B and C, and A is the superclass, B is the child class of A, and C is the child class of B. In other words, we can say a chain of classes is called the multi-level inheritance. And here this derived one class is derived from the base class, and this derived two class is derived from derived one class. So this derived class acts as both base and derived. And see here, dear friends, let me just make it in a detail with an example. So see here, so vehicle is base class, and here car is a child class of vehicle. And when coming to the sports car, it is child of car and it is not directly child of vehicle. Kindly have a note of it. So here when we just make use of the sports car object for a sports car, and here how it just moves on is, so here it just goes for the multi-level inheritance, so directly which is interrelated to that of the main base class. So it is not just directly make it into the inside sport car and inside car and inside vehicle. Actually, inside vehicle would be the first, and next it just gives the car info, and next is the sports car class. Okay, let me just see with one more example, dear friends. What we need is, see, we are here in class animal, we are here in class dog and class baby dog. And when we just make use of the function, that is the class, and we are in multi-level inheritance, and we are creating a object D of baby dog. And what is baby dog? Yeah, it is the class of dog. And what is dog? Yeah, it is the derived from the animal. And what is animal? So from that it just specify the exact functionality. And even though, see here, dear friends, here it just make use of the d dot eat. Yeah, it is just going to specify eating, and d dot bark. Yeah, it is just going to call the method of bark under dog of animal, and it just specify barking, and at last it's weeping. So let I just execute. Yeah, here it is the output. Okay, next is just the hierarchical inheritance. Dear friends, in hierarchical inheritance, more than one child is derived from a single parent. In other words, we can say that is one base class and multiple derived class. Multiple derived class. So base class is here, and the number of multiple inheritance is, sorry, hierarchical is a multiple number of derived class, for derived class 1, derived class 2 and derived class 3. And let me just see it with an example. So class 1, which is the base class vehicle, from there we can inherit, that is derive a class car and a truck also. And see here, dear friends, when we just create object 1 of car and object 2 of truck, and each and everything are separately having its own function, where car and truck won't get interacted, as each and everything are having its own function methods. So when I just create an object of car, yeah, it just gives the info of Yeah, this is the vehicle and the car name is this one. And when I just create a object for truck, that is also, it just gives the name according to that. Yeah, it is the info. So this is the vehicle and the truck name is this, as like that. Here it is just specify as a Ford. Let I execute it and kindly have a note of it. So this is the vehicle, car name is BMW, and this is the vehicle, truck name is Ford. Okay, next one, dear friends, it is hybrid inheritance. When inheritance is consist of multiple types or a combination of different inheritance is called hybrid inheritance. You can just have one base class. From that base class, you can just create two derived class. Okay, let that two derived class would be base for the third derived class, and even though it can add it from the base class or not. So there are so many combinations here how the exact function can be handled. And see here, let me just go for an example with that. See, class vehicle is the base class, and class car is derived from vehicle, and class truck also derived from the vehicle. But when I just specify sports car, it is just having the multiple inheritance as from car and the vehicle. Multiple inheritance from the car and the vehicle. And see here, dear friends, you can also have as a sports car, it can be just making it a car and vehicle. You can also specify some other vehicles and specify vehicle and truck. And even though you can just combine all the three, and you can just make a base class of car, vehicle and truck, so which is common among all these three. So that is how you can just make the base and the derived class. And see here, we are just not going to much take a risk or complex functionality. Just a simple, we are just going to create a yes underscore car as the object of sports car, and which is having the base as car and vehicle. So what is the base and car and vehicle? So it can be having the inheritance between the with the inside vehicle class and inside sport class and its own car, that is inside car class. So here it is all about the car and the vehicle of the sports car. So there it just being the output. So inside vehicle class, inside car class, and at last inside sports car class. Actually, to demonstrate the use of inheritance, let us take one more example. See, a polygon is a closed figure. Okay, so with three or more sides. So say we have a class called polygon, and here we are having small function, that is, see here, class polygon. It just has a constructor with a number of sides and function methods as input size and display size. And next we are having a triangle as one among the class, and to its self, that is the constructor, we are having a function, and find area would be the next one. And let I just execute both the function. Okay, so we are just created the two build functions. Okay, sorry. So here we have just built the two function is created. Now, when I just create an object of the triangle as T, okay, so what it just do, it finds the area. So this class has the kindly have a look of the both the classes. So this class has data attributes to store the number of sides n, and the magnitude of each sides as a list called sides. So that is what here it is specified. Okay, and the input sides where methods take in the magnitude of each side, and this display side displays these sides length. And a triangle is a polygon of three sides, so we can create a class called triangle in which inheritance from this class polygon. So this makes all the attributes of the polygon class available in the triangle class. So we don't need to define them again, which we just say code reusability. So let me just have the triangle can be how it can be defined. So we are just going to call only the triangle class and how it is derived from the base class as polygon. Okay, so see here dear friends, let me just make use of this triangle and how classes triangle have the new function method. Let me just have the input sides. Yeah, let me have the sides as we just enter as 1 second. Let me just enter at 3, and next one for the 2 we just have the 5, and let me just have the 6 as the third. And when on displaying the sides, so see here it just shows side 1 is 3.0, side 2 is 5.0, and side 3 is 6.0. And when on just calling the find area is in the sense the area of the triangle, where we have just I just scroll it above so that you can just see what is the triangle of that is area of that function. So here we are just having this triangle, and when on just calling that function, it would make the functionality how it is just making use of to find the area of the triangles which we have just specified the three sides. And here we are just provided, we can see that even though we didn't define the methods like here as input sides or display sides, for class triangle separately, we were using that by inherited, that is derived from the base class. That is what here. So here let me just make use of the find area, and the area of the triangle is 7.48. And kindly have a note of it dear friends, if an attribute is not found in the class itself, the search continues to the base class. So this repeats recursively if the base class is itself derived from the other class. So kindly have a note of that. Okay, let me just see it one more thing in a detail. See here dear friends, here we are having a parent class where we are just specifying that parent attribute as 100. Okay, we are just giving the constructor self thing as calling parent constructor, and a method calling parent method, and set attribute and get attribute where we are just making it for parent attribute. Okay, anyhow we have just provided the value for the parent attribute, and we are just going to make use of this functions to say, get and set. And you see here we are having a child function, okay, sorry, child class where it is derived from the parent, and here it is just going to have the constructor as calling child constructor once it is initiated, and then when we just make use of the calling child method, it just gives us this output and then go for the further process. What is the process? It just go for the initiation of calling parent method. Okay, so if we, for an example, see here dear friends, we have created an object C of child class. So here the instant of the child class has been created, and so it just calls the calling child constructor first, and next we are just going for child method, and next we are just making the parent method. And before to that, we are just going to set the attribute 200 and we want to just get the output of that parent attribute by calling the value of the parent attribute. And see here, we are just getting 200 dynamically when we just make use of the coding run. So it just specifying as 200, not 100. So it is overwritten. Fine. Let I just execute it, dear friends. Kindly have a look of it. So see here, calling child constructor, calling child method, and then parent method. There at last, here it is the attribute of the parent. Fine. Let me just see one more function, super function. So when a class inherits all properties and behavior from the parent class is called inheritance. So in such a case, so the inherited classes is a subclass and the later class is the parent class. So this is we have already seen. So in child class, we can refer to parent class by using the super class, and which it just returns the temporary object of the parent class that allows us to call a parent class method inside the child class method. And kindly have a note of it. What are the benefits of using this super function is we are not just required to remember or specify the parent class name to access its method. We can use the super function in both single and multiple inheritance, and at last this super function supports call reusability as there is no need to write the entire function. So here it is the example of that superclass. Separately, I have just specified here. So here the parent class company and the child class employee is there. So in employee class, we call the parent class method by using the super function. It is a built-in function. So when we just make use of this method, and if we create an object of an employee and it is which is inherited, that is derived from the company, so we are just getting the information to be printed as from the base class 2. So here, see here, the name, it is from the base class which we have just derived to in the derived class. So let I just execute it. See here, dear friends, this is how you can just make use of it. And last but not least of the day, subclass. And see here, dear friends, in Python, we can verify whether a particular class is a subclass of another class. So for this purpose, we can use the function subclass. This function returns true if the given class is the sub of the specified class. Otherwise, it returns false. And here it is the exact syntax of the exact function is a subclass, and the class here is to be checked, and this class info which is a class, a type or a tuple of a class or a data type. And see here, dear friends, let me just make use of it. The company, employee and the player, we have already specified a lot in the above. So whether this company is the base class, and see here, we are having the first function method as under the company, and next derived class of the base company, and it has its own method, and at last the player, well, it is a separate class which is not anything to be derived, so it would be a base of its own. And see here, dear friends, when I just want to check is subclass of employee and company, yeah, company is a base of employee, so which we have just specified in this the parenthesis. And when we just make employee is a list, the exact employee has data with a list. No, it is not in such a way. So it just comes false. And when coming to the player and company, see, player is a separate base class. It doesn't have any derived or any thing. So here in anyhow, it is not going to related with the class company. So these also would results false. And when just coming to the employee, see, this employee we are just going to have it is as a derived from a company. Okay, so that company, it just has a list of employees. So surely we will just have a list of employees there. It just specify whether it is true or false. Yeah, surely it is just going to have a true or false. And to the last, yeah, company is a base class, so it can be a base of its base or derived from its of the base. So here you can just specify the company, and to be true, yeah, it is one company or it can be one among the listed company. So here also it would be the true function. And see here, dear friends, we are just going to make use of this superclass and subclass, and just going to make more examples in the next. Is going to discuss about two concepts. One is method overriding and operator overloading. First, let me just move on to method overriding. In the yesterday session, we have just discussed about the inheritance, that is, all members available in the parent class or by default available in the child class. And for your information, dear friends, if the child class does not satisfied with the parent class implementation, then the child class is allowed to redefine that method by extending additional functions in the child class, which is called the method overriding. When a child class method has the same name, same parameter, and same return type as a method in its superclass, then the method in the child is said to be override the method in the parent class. So see here, if we are just having the same method in the parent and to the same here in the child 1, child 2, child 3. So these comes the exact example of the method that is overridden. Okay, let me just see it with an example, dear friends. See here, this is the class base class vehicle we are just having, and here we are having a method that is max speed under base class. And when we are just deriving the child class car from the parent vehicle, and here also we are having the method max speed, and we create having these two classes named vehicle and the car. The class which the car extends from the class vehicle, so all properties of the parent are available in the child. In addition to that, the child class redefined the method max speed. It is redefined here. And see here, dear friends, let I just execute the output. See, even we just calling the created an object of the cars vehicle, that is the child class, and from the car object, when we just define, that is calling the method from the parent or to the child class, it is redefined and we just get the exact output. Okay, let me just move on to the next example. See here, dear friends, here we are just having a small change in the method, that is my method, and where we are just going to print the calling parent method and calling child method. And to the same here, C is the object that we are just going to create it from the child class, and when we just call on to the my method function, that is the method here, and it just overridden to just call the child class and not onto the parent class. And here is the output. Kindly have a note of it, that is calling child method. Yeah, again we in detailed, let me just see it with a detailed example of this with a parent and a child class with having so many methods. Yeah, fine. See here, dear friends, this is the bird, the first parent class, which is the base class, and when we derive a child class penguin from the base class bird, and under the bird, the base class, we are having a constructor. And who is this? That is one method, and second method as swim. And when we are just making the same constructor for the child class also, here also we are just having the same init method, and next who is this, and last one we just have the run. Okay, see here dear friends, we are creating an object Peggy, and here we are creating it from the child class, which is the object of that child class penguin. And this Peggy, when I just call the uh, who is this, okay, who is this, where it just goes, exactly it just goes to the child class. And next, what is the who is this? So here also it just comes for the penguin, and again it just goes for the swim. Yeah, here it just goes for the parent swim faster. And next, for run, yeah, it just goes for the run faster in the child. So wherever it is overridden, so here we can just make use of this functionality. And see here I have just two functionality that I want to just check with the method overriding function, that is subclass or is instant. And see here dear friends, here when we just want to know for the both the things, yeah, subclass, yeah, penguin is a subclass of bird and Peggy is the instant of bird. So exactly, Peggy is instant of penguin, which is derived from the bird. That is the exact information that is also it is added to this example. Let I just execute this code and let me just see it. See here dear friends, so just I scroll it above to see the output of how the exact, yeah, for is instant of Peggy is bird, yeah, exactly here we just got the true functions. Okay dear friends, let I just spell some a small example related to this example of method overridden in penguin. Okay, sorry, in Python. So see here, dear friends, in the example, let me just go for a polygon and a triangle. Okay, notice that this init method was defined in both the class triangle as well as polygon. Okay, so when this happen, the method in the derived class overrides that in the base class. So that is to say, init in triangle gets preference over the init method in the polygon. So generally when overriding a base method, we tend to extend the definition rather than simply replace it. So the same is being done by calling the method in base class from the one in derived class. So here, when I'm just calling polygon init from init, which is going to be overridden in the triangle. Okay, a better option would be to use the built-in function here. We just used previously as a super function, where in the which we just say super function of init, which is equivalent to polygon dot in itself, and is preferred to learn more about the super functions in the Python. So let me just have here two more functionality, that is here this two also the built-in function, that is instant and is a subclass to check the inheritance. And see here dear friends, the function instant returns true if the object is an instant of class or other class derived from it. So let me just see each and every class in the Python. So inherit from base class object. And see here dear friends, notice that the init method was defined in both the classes, that is the triangle as well as the polygon. When this happens, the method is derived class overrides that in the base class. So this is to say the init function, which we are just saying here, the init function which is triangle get preference over the init function in polygon. See, generally when overriding a base method, we tend to extend the definition rather than simply replace it. So the same is being done by calling the method in base class from the one which is derived. And see here, dear friends, when on calling the polygon init function from the init, it would just overrides that in the triangle. Okay, so the better option would be to use the built-in function super function. Okay, and here when on, so we just use the super function, and see here, dear friends, it is equivalent to the polygon init function here, which we just specify in the triangle. And to learn this, actually we have already seen what is the super functions in the yesterday session, and today we are just going to discuss on to two built-in function, that is instant and is subclass. Okay, let me just see it with this example. And the function is instant, okay, would returns true if the object is an instant of class or other class derived from it. And each and every class in Python inherits from the base class object. Okay, let I just execute the polygon class and the another class, which is the triangle, which is the child class that we have derived it from the polygon base class. Okay, now here a instant has been initiated from the derived triangle. That is, here we are just going to say that is a class triangle. Okay, so here I just create an initiate from the triangle class. Now I just want to check whether, yeah, whether the t is an instant of triangle or not. Let I execute this. Yeah, true, it is an instant of the triangle. Okay, anyhow, we know that the triangle is derived from the polygon, the base class, and want to check whether the t is an instant of polygon or not. No wonder it is a instant of polygon also, because the polygon is the base class for the t instantiation object. Okay, now I just want to know what is the exact function which we just have, whether it is the instant, that is integer function. And I just want to know what is the t, and we have already just know how come we are just going to calculate the t. And see here whether int, the data object is in int. No, it is not an integer. Okay, fine. Let me just check whether it is an object. We just want to know whether t is an object or not. Exactly, t is an object of polygon, or if t is an object of triangle. Okay, similarly, is subclass is used to check for class inheritance. And see here, dear friends, is subclass. Yeah, polygon and triangle has been given. Whether polygon is subclass of triangle? No, it's not. It is actually, the polygon is the base class and the triangle is the child class. So how we have to say whether the triangle is subclass of polygon? Yes, exactly. See here, dear friends, it's so. And even though you can just check how about the boolean is an subclass of init. Exactly, it is true, because see here, when we just check with an integer, yeah, you can just say whether 0 and 1, it just comes under the boolean, and that would comes under the subclass of integer. Okay, next I just want to add up with a concept method resolution resolution order. That's in Python. See, in Python, method resolution order, which is short form of MRO, is the order by which Python looks for a method or attribute. First, the method or attribute is searched within a class, and then it follows the order we specified with inheritance. So this order is called the linearization of a class, and a set of rules is called MRO, that is method resolution order. See, dear friends, actually the MRO plays an essential role in multiple inheritance, as a single method may found in multiple parent classes. And here we are just given an example. In multiple inheritance, the search order, how it just be is, first it searches in the current parent class. If not available, then searches in the parent class specified while inheriting. That is from left to right. We can get the MRO of a class. For this purpose, we can use either the MRO attribute or the MRO method. Okay, see here, dear friends, I just have an example here. And here in this example, we create three classes: class A, class B, class C. And class B is inherited from class A, and class C is inherited from both B and A. When we create an object of the C class and calling the process method, Python looks for the process method in the current class in the C class itself. Then search for the parent class, namely B and A, because C class inheritance from B and A, that is C of this is B comma A, and always search in left to right manner. So here it just check for B first, and then it just move on to the A. That is how it happens. And see here, dear friends, let me just check for this output whether the is subclass of list and object. Here also you can just have that objects in a list. Yeah, it's true. And at last, the functions which we can just say whether the object which we are just having is a 5.5 is an instant of that object. Here we can just say whether if it is derived from class A, class B, or if we just do some multifunctionality. Yeah, you can just say yeah, it's true. And how about this instant hello object? You can also create an object where you just specify it as an instant of that object. Yeah, here too it is executed as true. Okay, added to this, dear friends, kindly have a note. In the multiple inheritance scenario, any specified attribute is searched first in the current class. If not found, the search continues into parent class in depth first and left right fashions without searching the same class twice. So, in this exact example above, say of multi-derived class, the search order is first one, it is multi-derived, that is the class C, and it just goes for the base class 1 and base class 2 and to the top objects. So this order is also called linearization of multi-derived class, and the set of rules used to find this order, which we already said, that method resolution order. And here, see here, dear friends, actually this method resolution order must prevent the local precedence order and also provide monotonicity. So it ensures that a class always appears before its parents. In class of multiple parents, the order is the same as tuples of base class. And here I just specify two things which it has to be added that. So see, if you just see this image, you are able to view the exact explanation. Okay, see here, MRO of a class can be viewed as uh, underscore, double underscore, MRO, double underscore, that is an attribute or an method. So here it is in the first line, it is an attribute, and the next one is the method. And the former returns a tuple while the later results here in the list. So that I have just specified in the line. And see here, dear friends, how this happens. So here, when we just make use of that m, the object, so here it just makes a multi-inheritance. It just moves on to that of order in A, B, and Z. So here, if it is this m is directly connected with A, B, and Z, so it is according to that. So but when here this a and b, it is derived from the x and y respectively, and here the b, it is y and z respectively, whereas all these three x, y, z's are objects. And see here, let me just demonstrate this MRO with an class definition. See here, dear friends. So here we are just having a class X, class Y, class Z, and this class, it is multiple inheritance, which is just from X and Y. And what about this B? Yeah, it is from Y and Z. And where in such case of M, it is B, comma A, comma Z. And how you just specify this m, yeah, let I just execute it and you just get it in a manner of a list. See, first it just goes for main m, okay, and where from the main m it is left to right. So first it just goes for b, yeah, here it is the b class, and next one it just a, yeah, here we are just having the a class, and next it's z. And see here, that z where it is one among the x, y, and z, so here it is in the order of x, y, and then z, and last it is an exactly object of that function class. So here it is. So this is how, dear friends, you can just make use of that order, how you are able to make the functionality. Fine. Let me just move on to the next method, that is, sorry, next concept, that is method over, sorry, operator overloading. Operator overloading, see, actually when it comes from Python operator, it just works for built-in classes, but the same operator behaves differently with different types. For an example, if we just take the positive operator, will perform arithmetic addition on two numbers, or it can just merge two lists, or it can merge, or it can concatenate two strings. So this feature in Python that allows the same operator to have different meaning according to the context, which is just called operator overloading. And see here, dear friends, for your information, Python operator overloading allows us to use mathematical, logical, and bitwise operator on Python objects. So what happened when we use them with objects of an user-defined class? So let us consider the following class, which tries to stimulate a point in 2D coordination. And let me make use of this in a class. And see, here we are just having a point class, and inside that is the method, that is the constructor we are just having. And once on executing this operator overloading in an class function, and see here the p1 is the object, that is an object of the class point, which we are just having the two attributes 1 and 2. When on just making this to be an addition or any other possibilities, and the next we are just having the p2 as one more object, where that point we are having 2 comma 3, and these are the two exact x comma y point. And when we make use of this point to be overloaded, that is positive operator, it can be as I have already said, if it is two numbers, yeah, it can just make an addition of two numbers, or if we are just having a list of two, it can merge the two, both the two, or if it is string of two, it would just mix the concatenation. But how about this class? Yeah, here I just on execution we got an error. We can see that the type error was raised. Since Python don't know how to add 2 point object together, however, we can just achieve this task in Python through operator overloading. But first, let's go get a notation about this special function. What is this exact special function here is, see dear friends, the class functions that begins with a double underscore is all called special functions in Python. So these functions are not the typical functions that we define for a class. And the double underscore init function we defined above is one of them. It gets called every time we create a new object of the class. There are numerous other special functions in Python too. Okay, using this special function, we can make our class compatible with the built-in function. And kindly have a note of this, dear friends. Here we are just having a point 2 comma 3. If I just want to print p1, what is there in p1? Let I just execute. See, p1 is an object. So the point object, instead of what we got exactly is, we can define a string. Actually, this is the exact coordination of the point object what we just got, but what we define is a string method to in our class that controls how the objects gets printed. Okay, let me just look how we can achieve this. And see here, dear friends, here I have just given you an example that how it going to come is when on just making the point initiation. Okay, so here if we just make use of this execution, here we just have a 2 comma 3, that is the exact point we have specified here in this previous example, and which it just turns out that this same method is invoked when we use the built-in function str or format. And here we are just having this function format. So the above example where we have executed, we just got an error as type error, as which the point is an object. And here we just got the exact point to be. Okay, now let me just make the str of that point, that is a string of that point. Yeah, 2 comma 3, that's being in the string, and the same thing in the format 2. Fine. So when we use this str of p1 and format of p1, so Python internally calls the p1.str method, hence the name special function. Okay, now let's go back to the operator overloading. Here what we just have is a class book, and we have an self that is a double underscore init method, that is a constructor with an attribute of pages, self and pages, and one more method double in underscore with add. So here it is the special function. And see here, dear friends, here what we just going to do is create an object, that is b1 with the class book, and again one more object you have been initiated with the same class book, but we have the different values, that's true. Okay, fine. In this, we operator overload, we overload the positive operator which is internally present, and the internally positive operator implemented by using the definition doubles underscore add with a special thing. So this method is known as the magic method. Yeah, exactly. It is the exact magic method, and let I just execute what it just would be. So here 150 added with 100. Yeah, here we just get the 250, the answer. Okay, let the same thing we just see it with one more example. Here we are just having the vector, and in that we are having one such method as double underscore str, and another was double underscore add from method, where that would just get the values from the user, and it would just gives the returnation of summation of that value, two values. And so here, when on just having the vector of 2 comma 10, and next one vector of 5 comma minus 2, which we are just going to create an object or an instantiation of to that of classes vector. And here when on just executing, we just get the output as 7 comma 8, where it is just adding 2 and 5 and 10 and minus 2. Here, see, actually to be true, that overloading the positive operator. See, to overload it, we will need to implement double underscore add function. This double underscore this add function. Okay, so that is the method which the function in the class. So with great power comes great responsibility, so we can do whatever we like inside this function only. So but it is more sensible to return a point object of the coordinator sum. Exactly. See here, how come we have just given in this example is, here it is a point of function, that is the class, and we are just making the double underscore str with an special function of double underscore add, where it is just going to return the two functions methodology, and it just gives the output of x comma y, where that would be the point. And I just want to make it in a detailed in this example. Kindly have a look of this, dear friends. See, here point is a class. It actually happens is actually when I'm just making use of this p1 and p2, we are just going to observe the method to be overridden, okay, overloading. So here we are having a point as a class, and inside that we have two methods. One is double underscore str and double underscore add, that is add function, where the Python calls p1 dot add of p2. That is when we just make use of that, p1 is equal to point of 1 comma 2, and here it just move on to that add function, that is add method, and which it just in terms goes for the add format, And after this, the addition operator is carried out the way we specified previously. And in Python, there are different magic methods available to perform overloading operator. Anyhow, before going to that, I just execute this, dear friends, and check for the output and see here when we just make use of 1 comma 2 and 2 comma 3, yeah, on addition of this attribute, and we just get 3 comma 5 as the result. And here I just want to add it with you that there are different magic methods available to perform overloading operators. Yes, dear friends, here it is the table just shows the magic method's name to overload the mathematical operator or assignment operator and relational operator in Python. That is what all here it just given. Okay, so here mathematical operator, assignment operator, relational operator, and last which we just specify the relational according to the bitwise 2 here it is given. And that's for all the day, dear friends. Kindly have a note of each and every concept. Do you have any doubts or anything, you can just let me know in the comment box. Thank you, dear friends. Have a nice